Good afternoon, everyone. My name is Ritu Chaturvedi, and my presentation is on a methodology that we proposed and we are using for many of our large classes that we use. So it's not very, I would say, computer science research, but I did use a little bit of text mining, and I'll talk about that. So, um, so this is my agenda. I'm going to introduce and then talk about the methodology, about a little bit of analysis that we did and the results that we got. So typically when we are, and I must say that I'm from the University of Guelph, and I'm a professor. I teach computer science. My interest is in computer science education, and which is why, let me start the slideshow instead of this. So which is why, my interest in this came up, because typically these days, I know technology plays a big role, and we do traditional teaching, which is purely you go to the classroom and then you teach the content to the students. These days, like I said, technology plays a role, so we do post our resources online using some learning management system, but that's the traditional method. Now, what I experienced in one of the universities that I taught in two of the courses that I taught at University of Toronto was where we used what is known as a flipped teaching method. Now, in a typical flipped teaching method, I can just talk about a little bit of pros and cons of that here. In a typical flipped teaching methodology, what we did was there was no teaching of any content in the classroom. We just brought worksheets or problems to the class, and the onus was on the students to learn the content on their own. So we had videos and we had some textbook which students were supposed to learn on their own before they came to the class, so that they could solve the problems with the instructor's help. And we wanted it to be a collaborative effort when it came to solving the problems. But I realized as an instructor, excuse me, that the onus was on the responsibility was of that of the students. There were many instances where the students would not come prepared for obvious reasons. They are students after all, so they won't come prepared to the class. And so we had this issue where students were supposed to get active learning, but they were not able to because they didn't come prepared with the lessons that they learned. So I introduced what I called it as a pseudo-flipped methodology, where I just took the best parts, the good parts of the traditional teaching and the flipped method. So what I basically did was, excuse me. So what I basically did in the pseudo-flipped method, and I'll talk about the class structure in a minute, where I did teach the content for that week, but I used that only 50% of the teaching time allocated to me, and the rest was spent on solving problems in class. So, and then there was an independent component also. Like I said, I will talk about that very soon. And the results were very promising. I still use it. I'm saying I still because this study started in 2019, 2020, and then we had COVID. So we had to, really everything went online. So we really couldn't pursue what I was trying to pursue in this research when it came to the pseudo-flipped method. But we are now coming back to that, and I'll talk about that in the future work section, where we are coming back to this, to the automated method that we could use for at least, to understand and to gauge what the students what works the best with for students when it comes to a large programming class in computer science. So the research question we were trying to answer was, does this pseudo-flipped method in large programming classes, improve student learning experience. And my focus actually was on engagement. Because I've been teaching for quite some time now, and I did get student comments saying that the lecture gets boring and disengaging and so on. So I did want to focus on the engagement aspect of it. So the methodology that I used was this. Now, the course context, as I said, was the first year programming classes, and we have large classes of close to 300 students in one section. So traditionally, we have in University of Guelph, where I am currently in, we have a 12-week semester. So traditional web-based teaching, like I said, is you go to the class, you teach the content, you post the resources online. We have some content which is in person. I should say most of the content in person, classes, labs, exams. But then there is some part that the students have to do on their own, where we do have an interactive textbook for that. So we had quite a few, like I said, close to 300 students registered initially, and then they dropped, and this was the final number that we got in the traditional classrooms. Now, the class schedule was 2 days a week, 1 hour, 20 minutes. So what I did when I was doing this experiment, I divided it into weeks 1 to 3, which was traditional, meaning I would go to every class and I would teach the content, and I would try and introduce the students to what is coming up, which is the pseudo-flipped method, where I took the Tuesdays where I taught the content to the students. And on Thursdays, we did these worksheets which had problems that we would solve together in class. And they were supposed to, there's an interactive textbook also that the students were given, and they were expected to do some exercises before they came to the Thursdays class. So the students did have some responsibility, but it was not a complete responsibility as it is required in a flipped methodology, teaching methodology. So that was the class context. Now, when it came to the actual material, we did a survey. We designed it using Qualtrics, and there were 2 surveys, approximately 10 questions in each survey. And this is again to show that quite a bit of my time was spent on getting the approval from the ethics board. And we do need to do that when we involve students or any human element in our research. And it did take a very long time, 6 months almost, to get my approval. Which is why I'll come to this, why I'm talking about the time that it took to get the approval and to pursue what we initially started with this in our research. So the 2 surveys that I used, survey 1 was actually done in week 4, which is where we had just barely started the problem solving worksheets that I was talking about. So the survey 1 questions are more about the lecture. I mean, do they really find it engaging and so on. I have a list of all my questions in the paper that I've submitted. But if you want, I can talk about the questions later on. So some of the questions were, did they find the lectures engaging? Did they enjoy the lecture at all? Because, like I said, boring was a tag that I did receive a few times in the beginning of my career. And I really want to change. I'm still working towards it, to change and make it more engaging for the students. And then, did you find the lectures relevant to the learning outcomes of the course that was being taught? And there were other questions as well. Now, the survey 2 questions were based on the worksheets that the students used. Again, the questions are similar. Now, were the worksheets engaging? Did you enjoy them? Did you feel that it helped you, write your own code? And then we also had an additional comment section, which was very helpful because that was where we did the qualitative analysis of the student comments that we got. These surveys were, because there was a research ethics board involved, they were administered by our educational developers from our university, and they were conducted in a lab session, which typically at the University of Guelph here in Canada, the labs are conducted by the teaching assistant. And that really helped me do the research, because I'm not supposed to administer those surveys, because there's a conflict of interest there. So it worked out very well that the surveys were conducted in the scheduled lab section. So the teaching assistants actually conducted the surveys. And then, of course, it was collected from the educational developers after the course was completed. We did, because it was done in a lab setting, I did assign a 1.5 bonus mark to the students who filled the survey, who opted to fill the survey. And for those who did not, we had to offer an alternate quiz, which was worth the same 1.5%. We got a good response again, because it was in a lab setting and students didn't need any additional time outside the class hours or outside the lab hours to do it. So for both the surveys, we did have a good response for that. Now, I'll talk about the analysis and a little bit more about my qualitative methodology that we had used when I talk about the analysis part. Now, the quantitative analysis was, of course, because there were scores we had used for each of the questions. So, for example, one of the questions was, did you find it engaging? We had 5 different options. Most definitely, somewhat, and so on. So I'll talk about the Likert scale that I used through one of these questions. But I think the most important question was, which do you think is a better teaching model for the course, for the large programming course? And we can see that some 69% of the students really said that they enjoyed the pseudo-flipped. And my graph is very, it's very misleading here, but it's actually more students. There were 75% of the students in the second section, winter semester, that gave these responses. So, I mean, we were actually gearing towards, when I say we, in this case, it was just me. I was really, the results were very promising already. But I did the quantitative analysis also. So if I'll talk about 1 or 2 questions which really made sense. For example, did you find the lecture or from the second part of the worksheet, the second part of the survey was on the worksheet. So did you find it engaging? And I focused on, so I really combined these two when I did my observational analysis, which is yes and probably yes. I just saw that yes, students do find it more engaging, at least, than not doing it, because the effort was from my part. I was creating the worksheet. Students really got a free grade when they did the worksheet. I did make it graded, to mention, because the first time when I started using these worksheets, I did not make them graded, and so the students really many students did not even attempt them. So I now have these worksheets as graded worksheets, and the students did find them engaging. Similarly, there was a question on did you enjoy the class at all or the worksheets? And again, the results were promising. There was a little neutral factor I did see here, and that could be because of the word enjoy. Perhaps some students didn't get what I was trying to ask. And I have this in my future, in my limitations, the way we design our Qualtrics survey might have impacted the results here and there. And then did it help you write code? And that, of course, students really felt that it did help them write their own code. And when I consolidated the results for the questions, especially the last 5 questions, 6 to 10, you can see that most of the results are positive when it comes to the worksheets. For example, if you look at question 7, the question was, to what extent do you think that the worksheets improved your learning? And there are quite a few students who gave a positive comment. Question 8, which again is really high here, 80%, it said, did you really feel that the teacher was helpful when solving the problems, because that was my job as the teacher, to not stand in front of the class and teach, but to be around. I did use help from my teaching assistants, because when it's a very large class, although attendance is not compulsory at our university, but students, whoever came, was able to get sort of a one-on-one help from me and from the teaching assistants that were there. So this was as far as the quantitative method analysis was concerned. When it came to the qualitative analysis, I'll start off with what we had planned earlier. So the initial plan was to use an text mining methods to do an automated analysis, or qualitative analysis, I should say. So text mining, I mean, so the plan was, okay, we take these comments and we pre-process them so that we can digitalize them, so that we can get a vector out of every comment, so that some data mining model can be applied to it. That pre-processing really took us a long time, because we started off with after you tokenize, the usual natural language processing steps. So the first step was tokenization, took a comment, tokenized it into different words, and then we applied stemming and lemmatization, took away the stop words. After doing all of that, we were able to store every comment as a collection of words, or features, I should say. But the problem again there was dimensionality. There was the huge number of words that we had, some 300 and odd words from all the comments that we had. So the number of features was very large. So we tested, we experimented on that as well. So one way was, we sorted them and we used the first top 100 words. We also used association rule mining to see with what are the words that appear together with a confidence of 80%. And then we just reduced our list to 33 words, and we used those also in our experiment. We used a bag of words model where, it just tells you the frequency of the words that appear, but we didn't get very good results. So we went on to change that to TF-IDF model. And then we were trying to cluster. So the whole intent of the qualitative analysis was, and I'll show you a graph, which was the actual intent. We wanted this automated method to give us different clusters of, for example, topics such as engaging, such as boring, such as helpful, and so on. But we were really not, with the time period that we had for the research, because we had spent a lot of time on the ethics and then a lot of time on the pre-processing step of it, we were not able to really come up with a good k-means clustering model for us. That's what we had intended for. After doing all of this, so we decided, just to wrap this experiment, I went with the manual method, where I printed all the comments and I passed for the common words, and added them as topics. And then this was an iterative process, exactly what a text mining model would have done for me, but I did it manually. And then this is what I got from it, which is, so I divided them into positive, negative, and neutral comments. So we had 19% had neutral comments, suggestions on what can be done for this. 3% didn't even attend the class, so they didn't have much to say. But the good part was that the 70% of the comments about worksheets were positive. 15% talked about engaging, how engaging they were. 56% talked about how helpful they were, helpful in terms of learning the material and in terms of solving the problem and then writing their own code for it. There were 8% that were negative, where students didn't find the worksheets helpful. They prefer the teaching method, and they did not write, they did not like the writing code on paper. very helpful. And this is very, very common with first year students, because we have a very mixed cohort with the first year students, where some students really know programming very well. So I assume it is those students who did not find the worksheets very helpful. The students who know programming really don't like to use paper when it comes to writing code or to do anything with the code. So I think those were the students who really had a negative comment about this. But the 70% positive was what I was looking for. And I did the same. So one of the example comments I wanted to bring in was that one of the students said that the worksheets worked well because they changed the class, because they made the class more engaging. It also helped to see different approaches to problems. Because even though they had an interactive textbook, when I brought up my worksheets, I actually had at least every worksheet had three to four problems, something that I could do in a 1 hour, 20-minute period. In fact, I shouldn't say that I spent the 1 hour, 20 minutes on the worksheet. I actually spent the first 15 minutes on a quiz on something that has been taught, and then we did our worksheet. So let's say we spent 1 hour on the worksheet, and the students really found it helpful because they could see different types of problems and approaches that could be done in a programming class. And I did the same experiment with the following semester, which was winter 20, and students more or less had the same, the same percentage of comments, except that there were more negative comments in the sense that the worksheets were boring. And I do understand where it was coming from. Like I said, there are students who already have learned programming from before, and so they find it not helpful or boring. Some students said that I must post it in advance, which I did not. I would print them and bring them to class. Even though the class size was big, I still believed in printing and bringing them to class. And so this is what I found. Now, going back to the automated clustering text mining method, this is an output that I'm expecting from the text mining method. And this is a more clear graph, so I brought the slide up again. Currently, if I can look at the clusters and I really see just the positive and the negative comments. I'm not able to see a cluster that will be about engaging, a cluster that will be about helpfulness, a cluster or a topic, one of the two. But I'm yet not there when it comes to an automated method. But this is the objective of the research. Does pseudo-flipped method work? Yes, it does. But then if I can, create something like this, it will be very helpful for the instructors, for the comments that they get from students. So in conclusion, a quantitative analysis of student survey responses and the qualitative analysis, they are indicative of the fact that pseudo-flipped method engages the class more than the traditional method. And students found the worksheets very helpful in learning the material and in applying them to practice, because we had a lot of hands-on exercises there. So again, the research question answered in a very promising way that yes, I do it for my third year classes and my fourth year classes as well, honestly, because the structure of the classes is Monday, Wednesday, Friday, and it really works very well when I do the Fridays, which is just for solving problems on the content that has been taught on the Monday, Wednesday classes. So I do use it for all my courses that I teach. But the main takeaway from this research was for me as an instructor, first of all, it was, make the worksheets more engaging. The students wanted to write code on a computer, which is not always feasible, but that was a comment that I received, and I try and do at least one problem like that in class and post them before class. So because some students really are very sincere and they would like to, solve it themselves before they come and discuss it with me in class. So as an instructor, like I said, the results were promising and I'm able to apply to it. Some limitations, one of them was the design of the survey questions. I think the way I designed was a little misleading and conflicting for some students, which is why I did not get the results that I was expecting. Secondly, because the ethics and all it takes a long time. I really was not able to correlate the performance with the results that I got. I would have loved to see for those 2 semesters, if the students are saying that they really liked worksheets, did it reflect on their grades? I was not able to do that. So that I thought was a limitation. And like I said, I couldn't have done it in those 2 semesters, honestly. And the third limitation was that I really had to, reconcile with the manual qualitative analysis method. It was still okay because, out of the 300 students that I had in every section, there were maybe 50% of the students who really wrote something, some comments. Some of them just would write a 1 word here and there, which was not very helpful. So I was able to do it manually, but in future work, currently, I'm actually working with a student to come up with some method that can automate this process of getting any student comment, not just related to worksheets, but any student comment, so that we can categorize the comments and give some meaningful information to the instructors. So we are working on automated qualitative analysis for this using topic modeling methods like LDA, and also clustering like k-means for that. Again, some of the rules we did apply association rule mining, but if I can compare the performance, I would have used rules like this, which again, I do plan to do it in future, where I want to see if students who scored a very high mark, greater than 80, really completed the worksheets, and if they completed it more than once, and so on. So that would be something that I would like to do in future, and correlate the performance of students with the analysis that I got. So that's about it. Thank you so much for listening to me.